Guys, we're about to get into the latest data coming out of the Lake Mead and Lake Powell corridor there. And as you see in the title, 9 feet, 9 weeks, that's about what the data is showing. And that's being very conservative because of the rising heat. It's hard to measure that, but we know it's going to be hot. Using the same metrics that we used in mid-May when we said by June 1st that Mead would drop to 1050, it did it exactly on that date. Now, what we're looking at here again, we're looking at the evaporation rate, the upstream feed, and the numbers. So don't go anywhere, guys. We're going to look at it. I'm not going to keep you long, but it's important. Now, the first thing I want to look at is the last 14-day averages at Lake Mead as far as elevation change, the inflow and the outflow of what we're seeing. And so what I'm going to do is pull this up into sections and use close-up, so if you're on your phone or something like that, you can get a look at it clear, because I know this is a lot of data for a small screen. Let me change that. Now, in this chart, we will get today's measurements tomorrow. We've looked at that. Now, there is a live one that gives you the hourly information, but here we're including, again, the 14 days. And so yesterday was here. Now, we saw an increase going back to 0.23 feet per day yesterday. And let me slide this over and I'll show you why. This is because really a couple of things, but you notice the inflow from Mead has been averaging 9,128 cubic feet per second for the 14-day period. But they lost about a little over 1,500 cubic feet yesterday as far as inflow. Now, I think it was maybe 2 or 3 weeks ago, we talked about the feds had decided at the Bureau of Reclamation to maybe salvage Powell, and then Mead would be the first to go in that chain if it happens. It looks like it's getting close. So you basically are putting out now double the outflow that you're taking in. And that's why, if we go back over, that you're seeing the 0.23 change as of yesterday. In other words, it dropped by 0.23 feet. If it was 0.25, it would be a foot every 4 days, right? But we have seen some 0.25s, 2.6s in there. So without having to do the math and cut it down and get the averages, let's just look at the elevation change. It really makes it a lot simpler. Friday, June the 19th, the elevation of Mead was at 10,046.26 feet, right? Now let's look at it yesterday, 1044.26. What does that tell you? A foot a week, right? That's where we're at now, 2 feet in 2 weeks. So that's where the 9 feet and 9 weeks comes from on the new math. Simply by looking at that, you can do it. But we need to look at Powell, and we need to look at a few other factors. I'm not going to make it a long, drawn-out video, but I'm going to put enough data in there to just keep you up to date on the situation that is happening there, so you'll keep your eyes on it. And we saw a couple of days of cooling just a few days back here into at least the 90s, but now it went to 100 3 days ago, or actually 4 days ago, 101, 102 now, and the low temps are in the 70s, so there's not a lot of cooling period time there. And the other factor is, if you average the inflows over 14 days, it's 9128, right? Outflows is 13030. But the average inflow going back since it was filled is 16,000. Average outflow 15,000 cubic feet a second. And again, if you look at the inflow average, 16, we got 9 here, so it's not quite half. But the numbers don't look like that when you look at the outflow. Even though this is nearly cut in half, the average outflow, guys, since it was filled is 15,500 cubic feet. But this has not dropped that much at 13,000. So you see a downhill drain, a downstream drain because of water and hydropower demand, especially in this heat, guys. And you got a lot of construction and things like that going on there. So remember, over high 90s to 100-degree heat averaging over that 14 days, we lost that 2 feet, foot a week. Just keep that in mind. And let's move up to Powell, because that is the upstream battery that keeps Mead alive during times like this. And had an elevation change of 15 feet down yesterday, and 3525 is the current mean sea level or the elevation. And the key number would be if this drops to 3490, then you get into tier 2 water restrictions and limitations on the turbines. So you're again dealing with 35 feet at Powell before it does what the 1035 is going to do to Mead. Now, again, problems going upstream to Flaming Gorge and all the way up to Fontenelle and the tributary rivers. Inflow has been cut in half. 51 cubic feet per second. Outflow 7,872 to keep, I think, some agricultural sections and Lake Powell propped up. So they're draining one battery after the other, and the upstream reservoirs are seeing the same thing. Remember, got forest fires, no snow melt, and record heat from the El Nino. All of those are contributing factors to what we are talking about. 9 feet, 9 weeks. That's where we're at 1035. And looking at the Bureau of Reclamation reports, if I'm not mistaken, they're still saying that we're going to get that 70% loss of power at 1035 because they got to cut off 12 of the 17 turbines. Remember that? And they may, again, step in and change the numbers, but with the fifth turbine down, you took out 20%. So you're about 80% or minus 80% of the hydropower going downstream. Again, the plans are to switch to some coal-powered plants, possibly gas or nuclear, like the one that's about 40 miles west of Phoenix. And but that may increase the cost of your electricity simply because hydropower is the cheapest power on the planet. And we've talked about Powell may not be far behind Mead because it's a strain on the entire Colorado River system. So let's look at the same 14 days. Friday, June 19th, Powell, was at 35.27.42. Now it's at 35.25.31. You see what I'm saying? Just a few tenths, less than 2 feet in 2 weeks. Now, unlike Mead, again, they've got 9 feet to go to that hydropower loss level. Then you're, again, in lockstep as far as a foot per week. And so what we're going to see is this inflow that we were looking at, which is half of the outflow of Lake Powell, that will escalate simply because you got to add in factors like the heat, no spring melt, and there is some ash blocking or getting into some of the upper river areas. And by the time it's at Mead, it's just a real fine ash. But I think they even have to filter that out in Vegas so the water doesn't taste like burnt smoke, right? But anyway, the further you go up in those steps of reservoirs, the more debris. It's like a system of filters almost. Some will even have floating trees in them that's up close to the forest fires. And that was not really a factor in any of these equations, but it is a real data point. It's just hard to know exactly how that's going to work out yet. Now, we've seen about 3 changes go on in the last couple of months. At first, we were going to get a 24-month report from the Bureau of Reclamation. Then, as they saw the problem between Mead and Powell, they stepped in and ordered a mandatory reduction to about 6,000 or 7 cubic feet a day, or an hour, released downstream to Mead, shutting it down. But they realized pretty quick that that wasn't going to work, so they jacked it back up to 8,000 and then 9,000 cubic feet per second on the output. That's lowering now. But anyway, they, on October 1st, the Bureau and the federal agencies are going to step in if the governors and the water managers of this whole river valley cannot come together. It was going to be on the 2027 report. They do a 2-year thing. They're realizing that it's a little more urgent than that. And so what they're doing now, and guys, this is coming out of the Arizona governor's office. It says, governors from 11 western states, including Nevada and Arizona, just signed a bipartisan emergency pact at the Western Governors Association meeting. Now, they don't talk about water much in it, but they do talk about hydropower and what they're going to have to do. It says, They are forming a rapid response task force to share grid loads across state lines and investing millions in federal grants for advanced control sensors to detect transformer failure seconds before they explode. In the very first videos of this series, going back a couple months, that was one of the first things we brought up, guys, was that we are dealing with an age of old transformers, and they're not easily replaced. And when you get this much heat in the desert, they can go out, especially, we're getting record El Nino heat. And we're going to look at a little more data, but here are 5 of the input points of that information. August heat is not peaked yet, and we're still July 3rd, guys, so we've got 2 months before that happens. Evaporation rates will climb higher than what's in the calculations. Powell cannot sustain high emergency outflows the way it's at. Number 4, the Rockies thermal radiator is expanding. What that is, if you've been watching, the Rockies are normally, they have snow and they're melting off, and you're getting the refill of the reservoirs coming out of the different rivers, but March took that out of, the March heat took that out of the equation. And so you've got an increased heat because of thermal radiation instead of alpine cooling on the top of the mountains, which some of them have been hurt by the forest fires. And then what has not been halted yet, and this is important, is the downstream agricultural demands remain locked in. I don't know how long will that last. Will it go all the way to October 1st, or will they see that emergency plans may need to step in to balance out some of the other things? We'll just have to see. But this is 5 of the things that we looked at, and there was a few others. Now, let's look at this. Today is July 3rd, 2026. That 9-week timeline puts us at September 4th, coming up here in 2026. Again, called the collision date. That's when the physics change at Hoover Dam quite a bit. 12 turbines, low head turbines shut down and leave 4 on the top. That's a pretty big cut, especially in the heat of the summer. Now, going in a little bit deeper, you're looking at side-by-side telemetry projection. This is putting the data in that we're using. It outlines the exact elevation differences as the El Nino heat block, zero rain, and downstream agricultural compress the timeline. And that downstream agricultural is the fact that they need moisture this time of the year, and that they have not put any regulations on it yet. And that's why you see big outputs from Mead right now. But again, starting both models at the average height to date, it's a little over 1044, it's 0.4, something like that. But anyway, putting those numbers in as a starting point today. Now, as we move down from this point here to date on both charts, and what the charts are, or what the listing is on the left, you got the baseline linear curve of 1 feet a week per loss. That's if linear means it stays the same rate of heat, evaporation, and all of that. But in a real world thermal curve is what it's called. You have accelerated evaporation and cuts. So you start at 1044 here. Within a week, there's not much difference if get to the second week in July. 1043. But at that time, we start to see the end of any runoff from March completely vanishes. So week 2, the metrics start to change. Again, left side is that linear curve of the data we put in today. If it does not change, week 2, we'll be down to 1042. But in the real world curve, we'll say 1041.8, because slowly adding in the variables, the heat increase, evaporation rate, and again, downflow cut. Now, week 3, 1041, if it stays linear, but it's showing 1040.6, and that's because of single digit humidity, and that air acts as a sponge. It will be up at that point. Now, getting into early August, week 4, 1040, that's the lowest, that's the record low, but using the other variables, the ones that increase, 1039.2. Downstream valleys, max out irrigation pumps. That's the time of the year you got to have water on the food, right? On the vegetables and the crops. Got to have it or they die. So it's going to be hard to cut that even though it's already in trouble. Now, week 5, looking at both of them, just staying linear, 1039, week 5. But looking at the, again, changes, 1037.8. You can see a slight difference. And this is because, guys, at 1040, that's record low. But anything below that, you don't get into the 1035 immediately where they have to cut the top 12 turbines. Guys, what happens is the weight of the water declines to where the pressure is not as much on the turbines. It's called head pressure, and it sags. The turbine efficiency drops even before they have to start the 80% cut at 1035. They're already seeing a pressure loss. And that would put it from 1039 again, just 1037.8. Now we're over a foot difference, right? 1.2 feet in week 5 between linear and here, adding in the real world elements. Now we're going to see the difference in the elevation of the lake change as we go through the weeks. Again, it'll increase per week. Week 6, we're down to 1038 as far as linear, and then you get to 1036.2 feet, adding in the other factors. So now we're almost at a 2-foot difference by week 6. On the 7th week, 1037 linear, 1034.4, adding in the new factors. Now, what is that, guys? We are now at a 2.6 foot difference. But just watch. Week 8, 1036, we're foot above the cut of the 12 turbines, actually 13. Anyway, but here at 1032 in the real world situation, guys, not quite 4 feet, 3.4 foot difference. Now, here's where we got to really watch the early date in September. Early September, we put it at around September 4th. Remember, week 9. 9 weeks, 9 feet. At that point, if we stay linear, no changing factors, 1035, we hit it September 4th. But look here, guys, we're almost 5 feet difference because of adding in the heat and elevation and the lack of upstream feed. So here at 1038 and 1036, we start to see critical threshold approaching. Again, below 1040, that starts to happen. You don't have enough weight, the same amount of weight on the turbines to generate the same amount of power. Then again here at 1037 and 1034, week 7, the crash point, it hits 1035 feet around day 48. Now, week 8, the cavitation forces the shutdown of the 12 low turbines. But again, going back to week 7, guys, according to the data, we are below 1035 by week 7, not week 9. Now, we are at week 9 if everything stays exactly the same. Now, with us going now into the 2 hottest months of the year, I wouldn't put money on it in Vegas that it stays the same. So again, we're looking at about a 5 foot difference, but that is where the linear hits the cliff. This is the linear again. Thermal is already 4+ feet past it. So just watching those end dates, those are the factors that we can use and try to get some reasonable outcome. Now, again, let's look at the divergence on it. The baseline curve, it runs at a flat 45-degree angle. It predicts hitting 1035 feet on September 4th. But if you add in the other side, that's week 9. And it completely assumes that the weather stays perfectly mild and downstream usage stays locked at spring levels. We're out of spring and we're out of spring melt. Anyway, but if you get into the real world thermal curve, the second column, it says this line starts to sag noticeably by week 2 as the Rockies thermal radiator pumps heat into the basin. Again, no snow. It's went from alpine cooler to thermal radiator. The line curves downward sharply. It drops from the 1035 foot marker by August 20th, 2026, completely wiping out the final 2.5 weeks of the federal buffer window. And unless somebody can come up with some rain, these numbers may be closer than the flat baseline. But it's only fair to try to put the baseline in and then put the other increasing factors in and see what we're getting. So we're going from 9 weeks, guys, to basically 6.5 weeks, possibly. Well, let's switch to the satellite images that are current now, guys, this afternoon. And we're seeing this low pressure system, but it's in very heated El Nino water, guys. Look at this. And we're starting to see that build in the Caribbean and some of the parts of the Gulf of America. So we'll have to watch for tropical updates. But guys, here's what we're focusing on. And this indicates the moisture is blocked from anywhere in the Pacific. And all the heat that is rising with moisture in it is being pushed back down and out into sea, right? All the hot, dry air is being pushed in, separated from the moisture, crossing all the rivers, getting into the mountains, and continuing to push east. And that goes on for a long way. Look at that. Now, if you go up to about 18,000 or so feet, guys, you should be seeing some moisture, even though the ground level, which we were just looking at surface level, shows no moisture. But look at what's happening because of this record El Nino. We're seeing quite a bit of changes on the planet. But the upper level winds have intensified in speed, of course, but they're just pushing the moisture away. Here, the El Nino pressure is doing the same thing. Right here, the water just can't get past this pushback point. It's like sending tentacles, like this one right there, guys, from an octopus. But these tentacles reach all the way to the Antarctic, and that's why we saw that 36-degree increase above normal there. Anyway, going up to that level, guys, it just does not show moisture being built up into the upper atmosphere. It's going to be some hot, dry times coming up, so it's best to be prepared as best you can. Stock up on some water, things like that, a little extra food. You never know. Now, guys, while we're talking about satellites, let's quickly switch over to some solar ones because the heat from the sun affects the El Nino and everything else we're seeing. And what has happened is we just saw one flare that is just below the X-ray level or X-ray flare level right there. And the second flare is in progress. The peak is not showing yet, means it's still climbing, it hasn't leveled out. So we don't know how intense this one is. But let's go back to the solar wind speed and look at how the incoming flare from last night played out. Now, if we look at this chart, I put up a video when we first started seeing the impacts of the incoming flare. Hadn't quite got here, but the energy in front of it had. And that's represented by this gold line in the middle right there. Again, solar wind speed, kilometers per second. But this line right here is kind of right as we were doing the video last night. I said, watch for this little jump to start to change. And the satellite's got a bump there. And they're kind of like an early warning system for planet Earth. Doesn't give you a long time, but it does give you some. Anyway, then we saw it start to rise. And then a second rise right there. See that? And then we got up in here to, let's see what we're at, in the peaks, over 600 kilometers per second. Now, where are we at right now? We're higher than we have been, and it looked like the main body of it was going to be in two sections. Remember the two curves that were going to dive slightly into the Earth, but maybe the tip of the two flares would catch us, and that's what we're seeing. This was the beginning of the power, and then we had a spike in here. And now we're seeing that get just a little bit hotter right in that area there. So the flare's still ongoing. One thing that is a little better up until this point was the shields that let in radiation to our planet were starting to close. But as soon as we got into the full section of it, we saw the shields open wide open again almost. But it's not as bad as it was here. There were no dipping of the two lines across the center gray line. This is a true opening, but we're just seeing going back and forth here just because you see the multiple flare effects coming from it. We're still in that. Again, you're more than likely, if you can in a position where you can see the auroras, you will definitely get a good show. Something else. Now, as we talked about in the video last night, that we were starting to get late in the day here on the East Coast, but getting into the West Coast and Hawaii and Japan and these islands, that as if it the intensity stayed intact from the incoming flare, then these areas would be exposed to a direct sun-facing event. In other words, you wouldn't be on the dark side of the Earth. And that's exactly what we saw. We saw a 6.2, a 6.1, 5.9, all on the side that was under the full sunlight. Check that out. And guys, when you get the quakes in this area of Japan, this was just a 5.1, but this is that fault zone that slipped during the 2011 earthquake there that caused a lot of damage. So all of these areas on the Ring of Fire. But let me back it out again. Again, the pressure came on this side of the Ring of Fire. There was some in California. We did see the Aleutian start to pick up. There was a quake here in Hawaii. But here's where the main pressure hit along this area right there. You've got, again, here's your 6.2, 6.1, 5.1, 5.9, right up into Kamchatka, Russia Island right there. And let's drop over to NOAA satellite just a moment. Here you can definitely see the drying effects of what we're looking at on the NOAA map, guys, showing the high pressure setting up here. Not much moisture at all at this point, just heat pushing in basically. And here's where the moisture is being trapped coming out of the Gulf of America and adding from the Caribbean also. So this is the hot spots right here, and you can see, we're going to zoom in some of these fires that they're dealing with. Now we're going back to early this morning and looking at what we're seeing here. Again, is the north of Sedona fire right there. But guys, right in here, almost obscured by clouds, is a massive fire right there burning on this front, or the eastern range of this section we've been watching. Look at that. It's spreading from south to north. And here, guys, you can see down into New Mexico. They're still dealing with the fires here. There were several smaller fires in spots around this area. One of our friends, Miss Tatton, sent some maps to me showing that some fires surrounding several little locations there. Maybe they have been better in control, but this seems to be the strongest area right there. Again, you've got New Mexico, you've got Arizona, you've got Utah and Colorado, and these are the main spots right now. I do want to point out, this valley needs a lot of moisture too, and I think you got Oroville Dam, some of the other feeds in that area. I'm not sure exactly what, but there is none being pushed inshore. Notice that it's being pushed down and into the warmer air of the processing El Nino, and just not getting the help you need, guys. Not going to go on with this any further. I think we got the data straightened out a little bit. Wanted to give you the heads up. Guys, remember, our Father loves you. We love you. And it is a heads up. Be safe. By the way, because of the algorithm changes in YouTube, they're saying unsubscribe and resubscribe, and sometimes almost daily, which is a pain in the butt. But in order to get past the point where you're not getting subscription notifications, not sure exactly how it's working. I know they changed some things. So just check that out if you're not getting these notifications. We'll see you soon. Heads up. Be safe.